Welcome back to MACSGATE. Okay, in today's session, we are going to discuss engineering mathematics through PYQs. So under linear algebra, let us take up the problems which were asked in GATE from matrix algebra and square matrices. The first one is this one. Consider the matrices X, Y, and P. The order of this particular matrix will be what? That is a question. What is the order of this particular matrix? My dear friends, if you consider P is a 2 by 3 matrix, X transpose is 4. X transpose means transpose of X, so it is 3 by 4 matrix. Then Y is 4 by 3. Then the inverse of this matrix, that has to be multiplied with P transpose. P transpose will be 3 by 2 matrix. And we have to take whole transpose of it. Now, if you consider this two matrices, when you multiply, you are going to get the order 3 by 3. So the inverse of the matrix also will be of order 3 by 3. Now remember, whenever you multiply two matrices A, B, suppose A is P by Q order and B is Q by R order, the product will be of order P by R. Okay. See, it's not necessarily for two matrices. Suppose if you are having A, B, C, D, E, F matrices. Suppose the first matrix is of order P by Q and last matrix is of order, say, S by T. Then the final solution matrix order will be P by T. So here also we can use the same logic. So this will be 3 by 3. Here we just need to consider the product of these two finally. That is the final answer, whatever solution matrix you are going to get, that would be of order 2 by 2. And when you do transpose of it, the order of that would be 2 by 2. He's just asking what is the order of the matrix. The order of the matrix is 2 by 2. So that is the solution, my dear friends. Okay. That is the solution. Let us take up the next problem. The product of matrices P, Q whole inverse into P is what? What is the product of these matrices? My dear friends, it's a very simple question. P, Q whole inverse into P. What is P, Q whole inverse? Which is Q inverse into P inverse. And you are multiplying with P. Now, what is P inverse into P? Because matrix multiplication is associative, we can multiply first Q inverse with P inverse, or you can first multiply P inverse with P. So I am using right to left association. So this is Q inverse into identity, which is nothing but Q inverse. So the answer is B for this. It is asked in 2008 IASC for civil engineering students. B is the answer. The next one. Matrix is given. Okay. If you are having any doubts, please ask me, sir. Okay. See, there is some issue with the chart here, chart option. So if you are saying something, I could able to visualize that, my dear friends. Okay. I'll be watching your comments, but there is a slight delay here. Okay. Kindly bear with it. Right. Now let us see this. X is equal to given and x square minus x plus I is equal to 0 is given. Then what is the inverse of x? See, one method for finding x inverse is adjoint x by det x, or there is one more shortcut also available for 2 by 2 matrices. The shortcut goes like this. If x is a simple 2 by 2 matrix like A, B, C, D, the inverse of this 2 by 2 matrix can be directly written as 1 by AD minus BC. Here, the main diagonal elements are swapped. D, A are swapped. Then the off diagonal element sign is changed. This is the formula, you can use it. These are the two methods. Or the third method which you use is the logical approach. So what we do here is x square minus x plus I is equal to 0. So here you multiply with x inverse. Multiply throughout by multiply by x inverse. When you multiply by x inverse, x inverse into x square is x inverse into x is identity, x inverse into identity is x inverse, which is equal to 0. So from this, what you get, x inverse value will be I minus x. So that is the answer. So I minus x means, my dear friends, I means 1001. That is, the main diagonal elements we have to write like 1 minus the elements of original matrix. And what about the other elements? Sign should be changed. For these two elements, sign should be changed, whereas these two elements need to be written as 1 minus of that element. That is, here we have to write 1 minus a. Here it is 1 minus 1 minus a. 1 1 cancel, minus of minus plus a, you get it. And sign of these two fellows should be changed. So it is minus 1 and it is a square minus a plus 1. So that is the solution, my dear friends, which is option B. Okay, I kept the place for solving the problem, but you don't need any additional space. We can solve within no time and within no space, right? B is the correct answer. Very good. The next one, which is a standard question, I think most of you can easily solve it because this shortcut most of the people know it. If you don't know, the idea is very simple. A, B, C, D, product of non-singular matrices is equal to identity. And if you want to find inverse of any matrix, that is, you want to find inverse of B, the logic is very simple. Just go circularly from after B and come up to B. Okay, wrap up. So what is B inverse, my dear friends? It is C, D, A, which is option B. Okay, someone is asking how A come. Let me complete this solution and tell you. This is CD. In the previous question, I think how minus A came. Which one? Where is minus A, sir? There is no minus A here. Achha, this 1 minus A. See, actually, you are doing it, sir. 1, 0, 0, 1 minus X. X means A1 minus A square plus A minus 1, and it is 1 minus A. When you do subtraction, you are going to get the answer, my friends. 1 minus A, then it is 0 minus 1. Did I written minus A here? Minus 1 only I written. Correct. Okay. Then it is 0 minus of this means A square minus A plus 1. And it is 1 minus of minus. That is 1 1 cancels. Minus of minus plus A. Hope you understand this. Is the idea clear? The next question. A is given and A inverse is also given. Then he is asking what is A plus B. See, again here multiple methods will be there. One method is find directly A inverse and compare, get the values of AB, then find A plus B. That is one method. Okay, try that. Okay, for that I already given the hint now. Suppose if A is ABCD, what is A inverse for 2 by 2 matrix? 1 by AD minus BC. Swap main diagonal element, change the sign of off diagonal elements. You try this. One more method is when you know that it is inverse of the matrix, you know A into A inverse should be equal to identity matrix. Okay. So when you multiply, you should get identity matrix. So on the left side, when you multiply A with A inverse, 2 into half is 1, 0. So it is 1. 2 into A, that is 2A, minus 0.1B. This is 0 and 0. This is 0. And here it is 0, 3B. So this is the value of A into A inverse, and this should be equal to 1, 0, 0. So from this, what we understand, 2A minus 0.1B is equal to 0, and 3B must be equal to 1. So from this, you get the value of B, which is 1 by 3. So B value, if you substitute in the other one, 2A minus 0.1 into B, that is 0.1 by 3 is equal to what? 0. So the value of A will be 0.1 by 6. Okay, because it is 0.1 by 6. 2 also goes to the other side, so 0.1 by 6. Now he's asking what is A plus B. You can easily calculate. What is A plus B? I think I have one more slide here. So A value you got it, which is, okay, let us directly write down A plus B. What is A plus B? Which is 0.1 by 6. What is B? B value is 1 by 3. So when you take LCM, LCM is nothing but 6, which is 0.1. And here it is 2. 2.1 by 6. Yani 21 by 60. 3 sevens, 3 20s. So 7 by 20 is the correct answer, which is option A. Option A is the correct answer. We solve this problem. If you directly remember, you can do it. Otherwise, do it with me. P is 4 by 2 matrix. Q is 2 by 4 matrix. R is 4 by 1 matrix. You want to multiply these two matrices, these three matrices. He's asking the minimum number of multiplications required. What about the minimum number of multiplications required? Here, friends, we can multiply the three matrices either in left to right associative manner or in right to left associative manner. This is called left to right association. This is called right to left association. But matrix multiplication is associative. So any order is fine. So let us find out the number of multiplications in both the orders. Whatever is giving minimum number of multiplication, that is your answer. Okay. So this is 4 by 2. This is 2 by 4. So when you multiply, you get some matrix, say D. The order of this matrix is 4 by 4. But to get this particular matrix, how many multiplications required? To get this particular matrix, how many multiplications required? P into Q into R. If P by Q and Q by R matrices are multiplied, number of multiplications required is P into Q into R. That is 4 2s 8, 8 4s 30. Now, here we are having matrix R, which is 4 by 1. So, finally, we have to multiply these two fellows to get the final solution matrix, whose order is 4 by 1. But to multiply these two matrices, how many multiplications required? 4 into 4 into 1, which is 16. So, if you do this order, we require 48 multiplications. We require 48 multiplications. So, let us try the other way. That is right to left association. First, let us multiply Q with R. Okay. Now, when Q is what, sir? 2 by 4 matrix. R is 4 by 1 matrix. When you multiply, let us say you get some matrix E. The order of this matrix is 2 by 1. And how many multiplications required here? The number of multiplications required here is 8. Then these two matrices need to be multiplied. Then you are going to get solution matrix. The order of solution matrix is it is 4 by 2 and it is 2 by 1 means it is 4 by 1. How many multiplications required to multiply P with E? 4 into 2 into 1. 4 2 is 8. 8 into 8, 1 is 8. So it is 8 plus 8, 16 multiplications. That is, we can get the product just with 16 scalar multiplications. So which one is minimum? 16 is the minimum. So that is the solution for this problem, my friends. So the answer for this problem is 16. Is the idea clear? Wonderful. This is very interesting question. So he's asking you to find the product K transpose JK. See, K is a 3 by 1 matrix. This is a 3 by 3 matrix. He's asking what is K transpose JK. So K transpose will be 1 by 3 matrix. J will be 3 by 3. K is 3 by 1. See, finally, the final solution matrix will be of order 1 by 1. That is, you are going to get single element. So he's asking what is that single element, my difference. Okay. So here K transpose is what? 1, 2, minus 1. And here it is 3, 2, 1, 2, 4, 2, and 1, 2, 6. And this has to be multiplied with 1, 2, minus 1. Okay. See, you can do one thing. You can multiply these two matrices. Then that you can multiply with the 1, 2, minus 1. Or you can multiply these two matrices. The resultant can be multiplied with 1, 2, minus 1. Okay. Any order is fine, my difference. Okay. When you multiply these two matrices, you get 1 by 3 matrix. If you multiply these two, you get 1 by 3. 1 by 3 need to be multiplied with 3 by 3. Any order you can try, my difference. Okay. So first, when you multiply these two matrices, first row multiplied with first column. Okay. That is 1, 3 is 3. You get 3 plus 4, 7 minus 1, which is 6. Then first row multiplied with second column. 2 plus 8 minus 2, that is 6. Then first row multiplied with third column. 1 plus 4, 5 minus 6, that is minus 1. And that has to be multiplied with 1, 2, minus So what is the answer? Single element you are going to get. That is 6 plus 12 plus 1, which is nothing but 19. Any mistakes, please check, sir. This is 3 plus 4, 7 minus 1, 6. It is 2 plus 8, 10. Okay, there is some mistake we done. 2 4s 8. 10 minus 2 is 8. So here there is a mistake. Please verify your calculations. Otherwise, things will go wrong. Am I clear? Please be careful. So what happens to this? 6, 16. Okay, 6 plus 16, 22 plus 1 only, na? 23, correct only. So that is the solution, my dear friends. The next problem. M power 4 is equal to I. M is not identity, M square is not identity, M cube is also not identity. Then for any natural number K, what is M inverse equal to? So here we can try this with just substitution method, sir. M power 4 is equal to identity. Multiply on both sides with M inverse. So when you multiply with M inverse, what happens? It is M inverse into identity, which is M cube, which is equal to M inverse. That is M inverse is equal to M cube. Now, M inverse is equal to M cube. You can multiply on both sides with identity. There will not be any problem. Let us multiply on the left side. Let us multiply on the left side. M inverse identity into M inverse is equal to identity into M cube. This I write it as identity into M inverse is M inverse only. But here, if you observe, M power 4 is identity. So you square it, still it is identity, identity square, which is identity. You raise it to any power, it is still identity. Okay. So I can use this idea that I is equal to M power 4k. So this I can write it as M power 4k into M cube, which is M power 4k plus 3. So the value of M inverse is equal to M power 4k plus 3, my dear friends. Is the idea clear? So the correct answer is option C. Got it? Wonderful. The next one. Here A and B are given. He is asking what is AB transpose. What is the value of AB transpose? He is asking. Wonderful. See, my dear friends, the most common mistake which people do is they consider it as AB whole transpose. No, there's a difference between AB whole transpose and AB transpose. This is AB transpose, not AB whole transpose. They are not same. So we just need to do A into B transpose. So A is 1562 and B is B transpose. That is transpose of it, which is 3874. Do multiplications, get the answer. 1 3 is 3, 7 5 is 35. You get 38. 38 in only two options. So C and D are ruled out. C and B are ruled out. Then again 8 plus 20, 28. That is only in the option A. So the correct answer is option A. A is the correct answer. Next problem. We are having an n by n array. It is asked for CS students, sir, n by n array or n by n matrix, you can call it. Okay. Instead of saying n by n array, we are calling it as n by n matrix. Okay. Matrix is a 2D array. It is defined as follows. That is, the elements are defined like this. Vij is equal to I minus j. See, when people see this definition, they leave this problem, my dear friends. Okay. Whenever they see, definitions which are given in double subscript form and other things, people directly leave those problems. Okay. But they are the very simple problems in the world. Okay. We just need to see carefully, read question carefully, understand the definition. Automatically, you will get the answer. See here, Vij is equal to I minus j. What is that he's asking? For such a matrix, he's asking sum of elements of the array. He's asking what about the sum of the elements of the array. Dear friends, You don't have to take a very big matrix. Just take 2 by 2 matrix. N is equal to 2. You just take 2 by 2 matrix. You'll understand the story. See, here you get A11, A12, A21, A22. So what should be the elements, my dear friends? See here what he says. Okay, instead of A, you can say V, sir, because the matrix name is V, na? So you can use V11, V12, V21, V2. So what is V11? See, V11 will be 1 minus 1, that is 0. What is V12? 1 minus 2, that is minus 1. What is V21? 2 minus 1, that is 1. What is V22? That is 0. What type of matrix is this? What type of matrix is this? It is the skew symmetric matrix. And for any skew symmetric matrix, sum of all the elements will be equal to 0, because main elements are anyhow 0, and off diagonal elements, if you are having Aij is suppose 5, Aj will be minus 5. So they both cancel out with each other. That is, every Aij, if you add with Aj, because they are all minus of each other. That is, every Aij is minus of Aj. They both cancel and you're going to get 0. So the total answer will be 0 for this matrix. So the answer for this problem is 0. So you can understand this like this with a general matrix also. This is 0, 1, 2, minus 1, 1, 3, minus 2. Okay, I'll just take 3 by 3 matrix. Writing general matrix would be very tedious. So, and here what happens? 2, 1, it is 1, it is 0. Here 2, 3, minus 1. 3, 1, which is 2. 3, 2, which is 1, and it is 0. See, if you add up all the elements, what happens? Automatically, main diagonal elements are anyhow 0, and these two fellows cancel out with each other. This cancel out with this, this cancel out with this, this cancel out with this. So sum of all elements will be, sum of all elements is equal to what? 0. So that is the solution. So that is the answer, my dear friends. This is a very interesting question. The number of different n by n symmetric matrices with each element being either 0 or 1 is what? See, here we are having n by n symmetric matrix. See, first of all, let us solve it for square matrix. Then we try to do it for symmetric matrix. See, if it is a square matrix, n by n means how many elements are there in this matrix, sir? N by n matrix means there are n square elements. I am just talking about square matrix, not symmetric matrix. It is a square matrix, not symmetric matrix. See, if you consider square matrix, there are n square elements. So let us consider those n square elements here. First one, second one, third one, and so on, n square. Now what is saying? Each element is either 0 or 1. So this element can be either 0 or 1, means 2 possibilities. This element can be either 0 or 1, 2 possibilities. This element can be either 0 or 1, 2 possibilities, and so on. This element can be either 0 or 1, 2 possibilities. So 2, 2, 2, how many times? N square times. So the answer would be 2 power n square. So if it is a square matrix, the answer is 2 power n square. But it is not square matrix in our question. It is a symmetric matrix. So if it is a symmetric matrix, okay, how many such different symmetric matrices can be created? Here, how many such square matrices can be created whose elements can be either 0 or 1? 2 power n square such square matrices can be created. But the question is, how many symmetric matrices can be created? Now, when you say symmetric matrix, what is the condition for symmetric matrix? My dear friends, for symmetric matrix, the condition is Aij must be equal to Aji. So, if you are having this particular main diagonal, the mirror images are same. So, whatever element is here, the same element has to be filled here. That is, if you fill 0, it has to be 0. If you fill 1, it has to be 1. So, we just need to fill the elements above the main diagonal. We don't have to fill these elements, because if I fill this, I know this element. So I just need to fill this upper triangular matrix. So first I need to fill these n elements here. In the next row, I just need to fill n minus 1 elements. In the next row, I need to fill only n minus 2 elements. And continuing in the last row, I need to fill only 1 elements. So how many elements we need to fill actually? It is 1 plus 2 plus and so on. I'm just going in this direction. 1 plus 2 plus and so on, n minus 1 plus n, which is sum of first n natural numbers, which is n into n plus 1 by 2. That is, we need not fill n square elements. We need to fill only n into n plus 1 by 2 elements. So the number of elements which we need to fill are not n square. It is n into n plus 1 by 2. This is this many positions we need to fill. And each position can be filled with either 0 or 1. Each position can be filled with either 0 or 1. So it is 2 power n into n plus 1 by 2 or n square plus n by 2. So the correct answer for this problem is option C. Of course, it is asked for CA student, but see, this is a general logical question. Even this problem can be asked in your aptitude also, my dear friends. See, in aptitude, you can get general counting questions, even probability questions, even such general logical questions also can be asked in aptitude. It's a general puzzle. Only thing which we need to know is what is symmetric matrix. Except that, rest of the things are very, very common, very general question. It is general puzzle. And there's one more question. A square matrix which is neither symmetric nor skew symmetric, and A transpose is its transpose. The sum and difference of these matrices are defined like this. That is, A is a square matrix which is neither symmetric nor skew symmetric. Okay, and A transpose is its transpose, and this matrix is written like this, my dear friends. Okay, that is, there is a matrix which is written as sum of A and A transpose. Sum of A and A transpose. Okay, and there's one more matrix D which is written as difference of A and A transpose. Which of the following statement is true? See, my dear friends, we know the direct statement, common or regular statement, common result. That is, every square matrix can be written as sum of symmetric. Of course, let me erase this. Every square matrix can be written as sum of symmetric and skew symmetric matrix. That is a straightforward result, my dear friends. So obviously this is your S and this is your D. So S is symmetric and D is skew symmetric. S is symmetric and D is skew symmetric, which is option D. Okay, so straightforward question, my dear friends. Directly the result he is asking, nothing more. Now this is a very interesting question, 2018 question. He given orthogonal matrix Q. What is the inverse of this matrix? Without putting pen on the paper, you have to solve this. Please tell me what is the correct answer. Waiting for your options. No one? See, my dear friends, it is orthogonal matrix. Orthogonal matrix means the inverse is equal to transpose. So it's just asking what is the transpose of the matrix. So where you find the first row is same as, first row converted to first column. Identify that. 3 by 7 minus 6 by 7, 2 by 7. Okay, this is the first column and it should be converted to first row. 3 by 7 minus 6 by 7, 2 by 7. And that is only in the option C. So C is the correct answer. Direct question, no twist, nothing. C is the answer. Now one more question. Matrix M is given and transpose of the matrix is equal to inverse. Indirectly saying it is orthogonal matrix. Transpose equal to inverse means what, sir? It is orthogonal matrix. And he is asking what is the value of x. Okay. See, my dear friends, when a matrix is orthogonal, okay, the columns, see if this particular matrix, which is 3 by 5, x, 4 by 5, and 3 by 5, it is orthogonal, the columns. Let us name the columns like P and Q. The columns forms orthonormal set. If it is orthogonal, means PQ forms orthonormal set. This is a beautiful result which helps us solving this problem very quickly. That means length of these two vectors should be equal to 1 and dot product of these two vectors is equal to 0. So just use the dot product, sir. What is dot product of these two vectors? Denominator is 25 in the first case, not in both cases. So let us see this. 3 by 5 into 4 by 5, that is 12 by 25. And x into 3 by 5, that is 3x by 5. It should be equal to 0. Okay. So let me complete this here. So denominator, it is 25. So 12 plus 15x is equal to 0. That means 15x is equal to minus 12. Yani x is equal to minus 12 by 15. That is nothing but minus 4 by 5. 3/4 and 3/5. Minus 4 by 5 is the answer, which is option A. Okay. So these are some questions which were asked in GATE. Okay. On matrix algebra and square matrices, my dear friends. Okay. So we'll stop today's session here. If you have any doubts, you can ask me. Otherwise, we'll call it a day. Thank you.